Hey, welcome back. Today I wanted to talk to you about Bool vectors. Bool vectors are a slightly underutilized, simply because I don't think there's awareness of them, part of logix. It came up in an office hours segment today, and so I wanted to talk about it. Check the video description for links to office hours information, but it's essentially a weekly event where I open up the stage in the bottom of the NeosVR Discord, and people can come in and ask questions. It's great. You can read the notes from prior sections. Any questions are open and available, but do concentrate on documentation, tutorials, and questions about how Neos works and stuff like that. There are other office hours segments, and you can check that on the office hours links. So we'll go ahead and talk about Bool vectors. So what is a Bool vector? Let me hop over into Smooth POV here. And here are Bool vectors. You can find them in input. Let me just head back here and then go to input. So you might be familiar with bool, which is just a single Boolean value, but you'll see next to them is bool2, bool3, bool4. So here's bool2. It's just a two element Boolean value. So you see it's got two x and y of false and false. You'll see bool3 as x by z is false, 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 false. And then a 4, which is x, y, z, w. So it's a lot like float2, float3, and float4. It just contains, instead of a float number, it contains a Boolean value. What might you want to use these for? So you might want to use these when you're packing, unpacking, or compressing data together, or when you're trying to do sort of more complex operations with Booleans, sort of when they have interrelationships with each other. I'll show you that in a moment. This can be useful for things like maps, where you want to do settings. For example, you could have different Boolean values for each sort of part of the map, or like a segment of the map, or switches within the map, and do different values based on that. And Bool vectors might be able to sort of speed that up for you, or make it easier to sort of reason a little bit about. It can also be used with the cloud variable and dynamic variable system to maybe save some space. For those who are unaware of cloud variables, there is a link in the video description to talk about the cloud variable tutorial series, but we are limited as users on cloud variables, and so you might want to use a bool vector rather than a single bool value to kind of get around some of the limitations by storing 4 Boolean values in one cloud variable. Same goes for dynamic variables. I'm going to show you how to use them. I don't have a defined use case for them, so this will be mostly theoretical, but I have given you some sort of example use cases to start. Going forwards, we'll be using the bool3. That's simply because it is the most mappable to a float3, which you should all be familiar with as it controls sort of position and scale within Neos. So here's the bool3 input node, and we're going to start using some other nodes with it. So the first thing you might want to know is how can you pull out the values? How can you separate those segments? And it turns out that it works with the pack nodes. So for a bool3, you'll need pack xyz. For a bool2, you'll need pack xy. For a bool4, you'll need xyzw. And the unpack nodes work just the same. So we can unpack them. I know these start as float, but you can plug in the bool vector here and it will update. So here you can see we've got the x component, the y component, and the Z component coming out, and then we can go ahead and repack those straight back into a bool vector. Got those the wrong way around. There we go. And so that's unpacking and packing. And like I said, that'll work for bool2 and bool3 and bool4. Just use the xyz and xy relevant components. So there you go. That's how to start using them. The moment I saw that this worked, I was like, okay, cool. I can use them now, because I wasn't aware of how to use them until I sort of realized I could separate their component parts. Another way of using them is to use the bool vector nodes. You can see these at the top here of the operators menu. So if you go to operators, you'll see bool vectors here. There are all, any, and none. I'll talk you through each one. All requires that all of the values within a bool vector are true before it will output true. So true, 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 that becomes true. If I change the middle one to false, it becomes false over here. Any requires that any item within the bool vector is true, and then I'll output true. So here you can see I've got two true values. If I change it down to one true value, you'll see we've still got true. If I change it down to no true values, you'll see it's false. You can think of this one a little bit like an OR gate. And then there's none, which requires all elements of the bool vector to be false before it'll output true. So here you can see I'm outputting true because none of these are true. Set the middle one to true, and it'll output false. So there you go. That is the all, any, or none nodes. They're quite good for bool vectors. You can also use this with the basic logical operations. So if we spawn an AND node out, and we plug in our bool vector, you'll see we get another bool vector out the side. What does this do? What this does is it will do an AND operation on each individual component with its sibling or other input component here. So what this will do is it will do x and y and output it as x. Not x and y, sorry, it'll do x and x and output it as the x, and then it will do y and output it as the y, and z and output it as the z. So here you can see in the middle here for the y value I have true, but true and false is false. But if I change this middle value here to true, you'll see that we get true out here. So let you do a lot of operations on those Bool vectors together, but also treating them separately. Similar thing with OR. You can plug this in and get an OR value. It would also work with XOR, which is this, and it should also work with NAND and NOR. So there you go, those are the nodes for that. You can also use it with a node which might not be obvious how to use it until you take a look at it, but that's mask in the middle here. I'm going to go ahead and grab my Bool 3 and move to the left a little bit as it's getting a little bit noisy over here and talk about mask. So mask can be found in operators, and we can spawn in just like that. I'll need that Bool 3 again, there we go. So now I'm going to plug in the mask Bool. The bottom input to mask is a Bool vector, so I'm going to go ahead and plug in my Bool 3. You'll see that it's converted to a uint node. Don't worry about that. We're going to go ahead and convert it to a float 3 variant by chucking in a float 3 input. There we go. So in this case, let's say that we have two coordinates. So we'll say, hey, 1, 5, and 3. And what we actually want to do is output a float 3 that has all of those components except the middle one. We want to set the middle one to 0, or actually want to set the middle one to, let's say, 22. What we can do here is say, hey, I want the x value, and I want the z value, but I want the y value from the second input. So I set the second part of the Bool vector here to false, and it's picking up the 22 from here and changing the y value here to 22. You can think of this like the ternary operator, but applying it to Bool vectors and float 2s, float 3s, etc. Frequently when I'm doing float-based operations on float 3s, I will do this equivalent, but I will do it a completely different way. What I usually do here is I'll take my existing float 3 and I'll times it by the parts that I want. So what I do here is I say, hey, I'll times the x by 1 because I want the x. I'll times the y by 0 because I don't want the y. And then I'll times the z by 1 because I want the 3. And that gets me 1, 0, 3. And then I'll add my target vector, float 3 in this case, to it. So I'll take this and I'll add this. And you'll get the same result here, but you've used a lot more nodes, whereas the Bool vectors and the mask node will get that done for you. This is great when you want to zero out a part of the equation, or you want to substitute in different values. Comes up a lot in sort of calculations involving gravity, or sort of scaling in one direction, or moving in one direction, stuff like that. So there's the mask node for you. There may be other nodes which work with the Bool vector system. The best thing I have to tell you about the basic principles of logix is just plug stuff in. It'll say no, or it might explode, but you're never going to get hurt, so just take a go at it and see what you can come up with. If you use Bool vectors in any sort of crazy scenario that you want to talk about, go ahead and let me know in the video comments. Oh, I did forget to mention, you can use them, I said earlier, but you can use them for cloud variables and dynamic variables. When creating the cloud variable and the dynamic variable, just specify the Bool 3 type. I'll do that very quickly. I know I sort of jumped around a little bit here, but I'll just grab any old slot here. If you go to data, dynamic, you can do dynamic value variable and then just choose a Bool vector, so Bool 3, and then that's a Bool 3. Or you can do cloud variables, cloud value variable, and again, there's Bool 3. And then for nodes, you can do it with just selecting them in the node browser, so variables, read dynamic variable, and then select Bool 3 again. And you get your Bool 3 out. There you go. Sorry about that jumping around. That's truly it. I will leave off here and see you next time for some more information that is about some other topics. Bye-bye.